Hello, everyone. In this series, we're going to talk about Statistics 1. And for the first unit, we're going to talk about, of course, Introduction to Stats or Statistics. Well, in this video, we're going to go through sample versus population, statistics parameter, and also types of variables. Before I get to what is the meaning of statistics, let's see first. So, statistics include numerical facts and figures. The largest earthquake measures 9.2 on the Richter scale. Men are at least 10 times more likely than women to commit murder. One in every 8 South Africans is HIV positive. Oh, yeah, by the way, I use a book as a reference, which is Introductory to Statistics by primary author and editor David M. And also other authors. I'll leave it on the description. One in every 8 South Africans is HIV positive. By the year 2020, there will be 15 people aged 65 and over for every new baby born. So the study of statistics involves math and relies upon calculation of numbers, right? But it also relies heavily on what the numbers are chosen and how the statistics are interpreted. For example, consider the following three scenarios and interpretations based upon the presented statistics. You will find that the numbers may be right, but the interpretation may be wrong. Try to identify a major flaw with each interpretation. Well, a new advertisement of Ben and Jerry's ice cream introduced in late May of last year resulted in 30% increase in ice cream sales for the following 3 months. Thus, the advertisement was effective. Well, without us seeing the advertisement, of course, in the next couple months, the ice cream sale must like increase. So a major flaw is that ice cream consumption generally increases, in the month of June, July, and August, regardless of the advertisement. This effect is called a history effect and leads people to interpret outcomes as the result of one variable and when another variable, in this case, one having to do with the passage of time, okay, is actually responsible. The more churches in a city, the more crime there is. Thus, churches lead to crime. Well, this doesn't account for bigger population. If a bigger population, this must be more crime, which has more churches. So, a major flaw is that both increased churches and increased crime rates can be explained by a larger population in bigger cities. In bigger cities, there are both more churches and more crime. Yeah, refers to the third variable problem, namely a third variable can cause both situation. The third variable problem we're gonna talk about later in the future episodes. However, people believe that there is a causal relationship between the two primary variables rather than recognize that a third variable can cause both. So, what can we conclude for statistics? So, statistics helps us to, of course, interpret data and also an underlying pattern, right? And also can make probabilities. So, there's two types of main types of statistics, which is descriptive and also inferential statistics. So, descriptive statistics is to describe, organize, and summarize raw data so patterns naturally emerge. The tools for it is measures of central tendency, which you maybe remember, which is the mean or the average, median, and mode. Measures of variability, which is the range, the variance, and standard deviation. And then we can use visualizations with it, which is histograms, pie charts, and scatter plots, and more. For inferential statistics, it's to draw conclusions, make predictions and answer what if questions about a larger population when surveying everyone is impossible, right? It makes sense if we can't just um, like survey everyone. That is impossible. So we have to like take a sample or a subgroup of a larger population. That's basically what's inferential statistics. And hypothesis testing, which is the t-test, ANOVA, and t-squared. T-squared. For this, I'm gonna talk about it on this series, which is statistics one. Relationships, correlation and regression, and estimations, margin of error and confidence intervals. I believe this is on statistics 2, right? Okay. And this is correlation and regression. We're going to talk about it later. An example of descriptive and inferential statistics is, let's say we're trying to count or measure the GPA scores of students. So let's say in a school, say we have 50,000 students, but we're gonna measure a specific class in it. So let's say we measure 50 students. Okay, so we measure 52 students, and we got let's say exactly average of GPA. Let's say X GPA will be 3.5 in the 50 students. So this simply describes those 50 students, right? So that's descriptive. Okay. How about inferential? So if inferential, we treat these 50 students as a representative sample. So we use inferential statistics to estimate the GPA for an entire school, the entire school of 10,000 students. So let's say we can conclude that average GPA scores of the 10,000 students would likely fall in 3.4, okay, and um, 3.6, okay. That's for inferential statistics. So okay, population versus sample. So a population is the whole, like the whole group that you want to measure. So it's this. If a sample, you take some of the people or some of the elements in the group, it will be a measure uh, to estimate the average of, so let's say, the deviation or the average GPA score again of those 10,000 people. Okay, or let's say another example would be if, let's say, voting, when it comes to voting, we can't really interview or survey all the people in the nation. We can survey a town, which will be like the sub subgroup for us to estimate the population's average, let's say average voting for person A or person B, like that. um so yeah, this is the example. High school students, every student enrolled into high school, so sample 50 students selected at random from the cafeteria during lunch. Streaming content population, every video available on Netflix. If sample is 100 randomly selected, yeah. All great white sharks in the Atlantic Ocean. The sample must be 20 great white sharks tagged while with tracking devices by researchers. So that's the difference between population and sample. How about parameter and statistic? The reason why I kept the graph of population sample is that parameter, this the numeric value that describes population. That's the parameter. If statistics is the numerical value that describes sample. Okay, so let's give an examples. Parameter, the exact average exam score of all 5 million AP statistics students worldwide. That's parameter. Statistics, statistic, the average exam score of a sample of 200 students surveyed. Let's say the actual percentage, which is 52% of all countries' total population that plans to vote for candidate A. The statistic, the percentage 54% of 1,000 surveyed voters who say they will vote for candidate A. The manufacturing example is parameter. Say the parameter is the true defect rate of all iPhones produced in a global factory. And for the statistic, the defect rate found in a batch of 500 iPhones tested off the assembly line. Okay, that's for parameter and statistic. Now, we go to types of variables. So there's categorical and numerical. So categorical is this basically the same thing as the qualitative. Okay, if numerical is quantitative. So categorical is split into two, which is the nominal and ordinal, while numerical split into discrete and continuous split into interval and ratio. So the categorical variables or the qualitative variables describe qualities, of course, characteristics or labels. For example, blood types. Blood types like A, B, and AB and O. That's for categorical variables or qualitative variables. How about numerical? If numerical variables is of course quantitative. Wait, I think I typed it 2 times. Okay. An example of it is number. Let's say number of cars. Number of cars. In a parking lot. That's an example. And temperatures. Okay. And also let's say shoe sizes. That's numerical variables. How about nominal variables? So nominal variables has no natural order or rankings. Again, it's the same thing as what I think I said before, which is the blood types. Blood types is there's no ranking in it, right? And also state of residence, yeah. State of residence doesn't have any order or rankings. How about ordinal? Ordinal have meaningful order or ranking. An example of it is, let's say, the satisfaction rating of a customer, which is satisfied, neutral, and dissatisfied. An example, the second example, let's say the socioeconomic status, split into three: low income, middle, and high income. Let's have order or ranking. And how about discrete variables? Well, discrete variables is number example number of goals scored in a soccer match. Values that are countable and typically distinct separable points. So it's not continuous. Okay, that's the next thing. So continuous variables, values that are measurable, that can be take on infinite number of possible values within a range, including decimals and fraction. Well, an example of it is an exact time of running a marathon. And another example is the body temperature over time. That's continuous variables. The second and the first last. So there's interval variables. Again, it's part of the continuous variables. It's split into two, which is these two variables. the interval variables have numeric values where the distance interval between any two numbers is equal and meaningful. However, they have no true 0 point. What does this mean? So has no truly absence. There's no absence. There is zero, but it's just within the range. So for example of it, it would be weight or height, right? So an example of it would be temperature. So 0 degrees Celsius does not mean like there's no temperature. It's just like the freezing point, right? So 0, -5, 5. So 0 doesn't mean there's nothing. It's just, this is, let's say, degrees Celsius. It just says the freezing point. Freezing point. So there's no true 0 point or true absence. Another example would be year date. Yeah, year or date. Year, which is, let's say, in a line interval, year 0, 1, 2, and so on. So this doesn't mean there doesn't exist a time before 0. There is a time before 0, but 0, it just lies within the range. That doesn't mean there's an absence of year before 0. So it's just an arbitrary starting anchor. Okay. Another example would be, let's say, IQ scores. A score of 0 on an IQ test doesn't mean the person uh, has 0 IQ or 0 intelligence. Okay. That's for interval variables. How about ratio variables? Ratio variables have all properties of interval variables, but they do not have a true 0 point. They do have true 0 point. An example of it would be, let's say, weight or height. If we have weight 0, that means, yeah, no weight. It has absence. Um, if income or money, having $0 in bank means you have absence of money. So there's a true absence. If a car travels like 0 meter per second or 0 miles, that means, yeah, the car haven't moved yet. So they do have a true 0 point. That's for ratio variables. Okay, that's it for today's video, and I hope you enjoyed it. Well, this is the first time for me to teach statistics, so I'm sorry if it is not clear yet, and I hope I could be better on the next video while explaining. And so that's it for today's video. Thank you. See you next time.